All right, take two. Okay, welcome to another AddOhms live stream. This week's topic is going to be Eagle 9. Um, this is also the first time I'm doing a restream, so I'm actually streaming simultaneously to YouTube and Twitch. I don't know how often I'm going to do that because I'm not sure how that works out, but let's see how it goes with this stream. So I'm James, the Bald Engineer. I host and run the AddOhms YouTube channel. You can also find me on baldengineer.com, where I do my weekly blog. This week, as I mentioned, we'll be taking a look at Eagle 9. So last night, I downloaded Eagle 9 for the first time. Well, let me rephrase that because that sounds wrong. So Eagle 9 was released this week. I downloaded it, installed it, made sure it ran, and then I have some ideas on how to take a look at it because it's been 5 years since I used Eagle day to day. Lately, I've been using KiCad, which I'll get to in just a second, or I'll touch on in just a second. So what we're going to do is I wrote a training class for Eagle. And so we're going to look at that and just see if there's any kind of new things in terms of basic usability. And then there's a blog post that the Eagle team put together that goes through some new features. And then we'll see if there's any questions about Eagle or if I find anything along the way. Okay, so chat's going. Streams look live. In the chat room, can you let me know if you can hear me okay? While I wait for you guys to get to that, I'm going to head over to my web browser. Okay. Yep, sounds good. Okay, awesome. So the first thing I wanted to point out is there's links in the description, and I'll have them available after the show. So there's a blog post on what's new in Eagle 9. So wanted to check that out. Now, something that comes up a lot, and I try to wear interesting t-shirts with every video I do. And so if you want to get a Never Trust the Auto Router shirt, then head over to Contextual Electronics. Again, link is in the description. There you can actually pick up one of the t-shirts that I'm wearing today. This is also the same shirt I wore in the MOSFET video. Well, it's the same style shirt. That was actually a very different shirt, or a physically different shirt. Yeah, anyway. So there's that. And then in terms of schematics and printed circuit boards, don't forget I do have 2 episodes. One on a DIY Arduino schematic, which I used KiCad, but hey, as I said in the video, don't get caught up about that. And I also did a PCB episode. Now, since recording the PCB episode, I have received back the boards. In fact, I have 2 versions of the board, one with a mistake and one with hopefully without. So I'll be working on that episode very soon. And basically what I'm going to do is populate the board, throw it into my reflow oven, and it's converted toaster oven, and then do some testing with test equipment to turn it on. So I think that'll be a kind of a cool, like, hey, if you build your own Arduino, here's how you get that thing going. So I wanted to make sure you knew about that. And then lastly, I do have a link to a Eagle tutorial I did a very long time ago. This was actually one of the first video tutorials I ever. So let's go ahead and let's see. Eagle is here. I'm gonna do this. I'm gonna make it full screen in just a second. And then I want to show you guys, okay, so for the first part, what I'm going to do is I wrote this training class, and I wrote it for a makerspace with the intention to sell it to them. They never bought it, and I'm sort of glad they didn't because now they're out of business. And so what I thought I'd do is I'm just going to sort of run through what I had set up in this Eagle training on how to build a 555 timer. And so this is a pretty simple circuit to build, only takes maybe 10 or 15 minutes to go through, but it helps to give me a chance to reacquaint myself with Eagle because I haven't used it since version 6. Excuse me. Now, what I mean by haven't used it, I just realized, so I have used it on and off, but I haven't done a serious design with it since maybe 2014. I have used it to edit other people's work or look at boards from, say, like Adafruit. In fact, a very common thing I had been doing with Adafruit stuff is download the Eagle file and then convert it to a 3D file so I can use it in a CAD program. But anyway, so we're just going to kind of run through this. It's a basic 555 timer. So double bonus in this tutorial because we'll be talking about how to do a monostable multi-vibrator. All right, so Eagle, this looks about the same as what it used to be. Have my projects. Okay, Spice models, that's new. Cam jobs, scripts. I wonder if they're still using, yeah, it looks like they're still using their own scripting. That's okay. Design rules, libraries. What's going on here? Oh, wow. Okay, so yeah, this computer still has my really old libraries. A very long time ago, before I settled on the name AddOhms, I was actually thinking about calling my channel and my company JitterLab, and decided not to. But the original library I have is JitterLab, so that's cool. All right, so cool. Yeah, I wasn't sure what's going to be on here. All right, so let's just do this new schematic. I need this to be about, where's the chat at? This far, this wide open. All right. So schematic, or how you do, or the block diagram for doing a PCB. You have an idea, draw the schematic, lay out the PCB, manufacture the PCB, place the parts, and test. And actually on the DIY Arduino stuff, we are at create PCB right now. Okay, so this is the schematic we need to build, and I'm just going to sort of make this so I can see what I'm doing. I realize in the chat, let me move this over real quick. I realize in the actual stream, the chat is overlaying this window, but I'm drawing the schematic, so I don't think you really need to see it clearly. But if you do want to see it clearly, there it is. Okay, so the first thing I've noticed, just looking at the menu bars, all of the icons are new. And a little conceit, actually, I think these changed in Eagle 8. I saw a presentation from one of the UX designers, and she was talking about how they did all new icons. And so, for example, this button is probably my favorite because it switches between schematic and PCB. And before, it was just sort of a vague picture of the two. So now it looks like it's a toggle that goes between them, the scripting, and then some of the tools over here. Now, I think a lot of people, when they start to use Eagle, something they sort of miss is that this is not a vector editing program. So like in like Inkscape, you know, you might be able to just go and start drawing shapes. Well, you can do that sort of in Eagle, but Eagle's not really a vector program. It's a CAD program. And unfortunately, something I noticed last night is it still has a paradigm that reminds me of the very original Autodesk, which is it's a command based system with a GUI on top. So for example, if we want to add components, there is an add, is this it? Design block, add. It brings up the add dialog. But there's also this command line. And in fact, I've got a blog post on this on baldengineer.com. You can just type in commands. Now, one thing they did add, and I noticed this just now, and actually somebody told me about this, is that it auto-completes the command. So if you want to add, copy, route, wire. And so what you're actually going to see me do in this stream is I make use of that, I make use of the commands way more than any of these tools over here. Yeah, I agree. The sidebar basically looks the same. I think the icons are definitely different. I don't recognize like that add. It's a slightly different icon, but layout looks about the same. All right, so let's do add. Now, something I didn't like before was searching, so I need this 555. So if I type in 555, nothing comes up. Well, I guess that means the stream is over. No, just kidding. I bet if I add a star, yeah, that still kind of bothers me. I feel like this search should be a little smarter, but okay, whatever. Okay, so this is actually a schematic symbol that I created, and I did it on purpose so that it gets laid out really nicely. So let's go ahead and add that one. And I'm going to place it here. All right, hit escape, should come back on. All right, so now we need 1, 2, 3 resistors. RES star, resistor. And I'm going to go with 1206 surface mount. So in this class that I wrote, the original idea was that you would actually mill this PCB on a shop bot. And so I had to design the circuit so that it could be easily milled on one side. And I'll show you at the end what my final design looks like, but you did need to use 2 vias because you had to loop 1 wire. All right. 1, 2 capacitors. And again, we'll go with 1206. Actually, well, if I was really building this, I would actually use 805s because I recently stocked up on 805 components, but I still have a bunch of 1206s and I'm not going to make this one anyway. Okay, I feel like there should have been one more, but okay. And then let's add an LED. And again, now LEDs, I know I have a ton of 1206 LEDs. I just like how bright they are. They're a lot easier to work with. Now we need to add a ground. No, that's not gonna work. I like this one. So I had an interesting comment come up in the in the comments this weekend. First, I got a very impolite email or comment saying that I left out half of the circuit and that it was impossible to follow, which is partially true. I don't always draw the entire circuit in my videos or whenever I'm explaining things, because I kind of assume, you know, most people would know that if a signal's coming into, say, the base of a transistor, that means a signal from somewhere else. But what it turned out was the person was confused because they didn't realize the ground symbol was representing ground. They didn't know what ground was, and that all ground connections were connected. And so it was kind of telling for me because, you know, sometimes I think we forget where certain people are coming from. You know, yeah, ground seems pretty obvious to a lot of us, but if you don't know anything about electronics, first you have to get over the fact that ground in digital isn't the same as ground on the earth. And you have to think about, when you look at a schematic, you know, where things actually connected. All right. And then we need to add VCC. In this one, I used to use the circle, but I like this guy better. We're going to add this and add this. Oh. I totally missed. Okay, so we need this one. And then I had M02 header. Now, okay, just a note, and I think the Adafruit Eagle library has this as well. And I don't know how, I haven't updated the SparkFun Eagle library for forever. This is probably the last time I used this a couple years ago. But they did have, for the header pin connections, they had something called lock. And if you look at, okay, look over here where my mouse is at now. Notice how the circles are perfectly aligned within this silk screen. Well, they have one called lock, and this is actually really cool because it's offsetting the pins. And so what that actually does is when you go to put the header into the PCB, it actually causes it to like get stuck. And so when you flip the board over to solder, the pins stay in place, which makes it so much easier to solder. So if you're using header pins, go ahead and use these like offset holes. Now you have to be careful, like if you had these placed next to each other, you wouldn't be able to get a trace between this and the next one. But offsetting or having these lock steps are just makes soldering so much easier. All right. Okay. So I need one more ground, but instead of adding it, I'm going to copy it, but I want to talk about something first. Let me just double check on the chat real quick. While one waits. All right. So an eagle is linked to the component. Let me answer a couple of these questions. So search is still unusable. I actually have a blog post on how to make it more usable. I think it's hopefully getting better, but yeah, it's about the same. Okay. Let's just do a quick ban that one. Let's see. Eagle footprint is linked to the component you placed, unlike KiCad. Yeah, actually, schematic symbols and footprints are tighter linked. Now, I do think in KiCad, I think it's called Atomic maybe, you can actually link them together. And I would like to come back and look at KiCad 5 or KiCad 5 and understand how the new component library works, because I haven't really dove much into it. I've been using the nightly builds for a few months, and I mean, it's a big improvement over the previous version, but I'm not sure where it's at. All right. Okay. All right. Let's get back to using basic stuff. Okay, so for this header, basically the idea behind this header was I want to put a 9-volt battery into the circuit, so, or solder a 9-volt battery into the circuit. So I'll need one more ground connection. So first, let's highlight this one, delete it. And this is actually where, let's see if this works now. Can I do copy and paste? Okay, so that works, but the thing is, I never did it that way. I always did it this way. So up here in the command bar, I would type copy, select the device I want, and then it automatically is now being copied. And so this goes back to what I said earlier, where Eagle is really like a GUI on top of a command line system. So like if you think about what I just did was I told the back end I want to copy something, and then you select what you want to copy. I know it's not as intuitive as say like a lot of more modern like drawing programs, but from a CAD perspective, I'm not entirely surprised that it still works that way. And I think we can also right click and then you get contextual stuff like copy. So that still works too, but yeah, okay, that's fine with me. All right, so 2 resistors, 3 resistors, LED, capacitor, over here was a header pin. Okay, so now let's wire it up. And okay, that's going there. And then CV goes to this guy. We need to move this wire. Yeah, you know, I know a lot of people get upset about the way that Eagle works, but really, I feel like it's of the entry-level CAD tools available, and I would argue that Eagle and KiCad aren't just entry-level, but I think a lot of entry-level people look at it because of their price tags. I think it's actually the most consistent user experience of, say, KiCad or Eagle. And what I mean by that is once you understand how it works, everything sort of works around that same paradigm. It's not like KiCad where you go in and first it's 12 different separate applications. They all have different hotkeys. They all have a different paradigm. Now it's getting better, but I think once you get over Eagle's learning curve, it's the most consistent user experience. Maybe not the most intuitive user interface, but it's consistent. Now the other thing is, keep in mind, I guess it's since version 8 that AutoCAD bought Eagle. And so I have watched AutoCAD go from the DOS AutoCAD to some of their first GUI stuff. And then a couple of years ago, actually about the time I was using Eagle, I started learning AutoCAD Inventor. And that was sort of the first time when I started to see something that looked really interesting. And now that I'm using Fusion 360, which lately on this project I'm working on, I'm using it every day, it's really good. And so I think one of the benefits that we'll see eventually, hopefully by the next version, is that we'll see some improvements here. Anyway, enough of my ranting. So now that I've talked about why we need some improvements, here's something that baffles a lot of people when they're using Eagle, and that's how do you move a group of components? So for example, I need this wire to go from here to the top of this resistor, but I don't want to draw it all around. So I want to just move these two components down. And so if you try to, like, say, draw a box around them and then grab, oh, okay. I tried that last night, it didn't work. Okay, so moving groups of stuff actually works now. Okay. See, in the past, what you would actually have to do was you had to highlight it, tell it you're going to move, right click, and then choose group. But cool. All right. I don't know when that got fixed, but I'm really glad to see that finally. All right, let's get back to doing some wiring. That's actually, there's something about that highlight that is actually working a lot better than it used to. Now, granted, keep in mind, not everything I'm looking at right now, this isn't really specific to 9. I haven't really used this for so long now. I wasn't sure what the new stuff looks like. All right. Now we need to go from discharge to here, and then trigger and threshold go to this RC, and then we're going to do that. Awesome. All right. Now, one thing I'm going to do, I don't think it's necessary, but I think from a schematic perspective, we're going to add junction points. So here I have 3 points coming together, so that's supposed to be there or connected. Here I have these two coming together, and then those two going together. And I think that's what I did in my original. Okay. All right, so the pieces are in place. Got one more step. Let me double check what you guys are talking about. Can you just Control C, Control V? Good question. Yes. Okay, so copy paste works. The thing that might trip people up is it looks like the duplicate appears right on, so that's Control V, Control V. Yeah, might only mess you up because the duplicate gets stuck on top of the old one, but I mean, I use Illustrator quite a bit, and it's brain dead when it comes to pasting, so that's actually not a big deal to me. Technically, you're pasting things by clicking. Yeah, I was. Yeah, actually, regarding the keyboard shortcuts, the only reason I don't use the keyboard shortcuts is when I was using this before, I was switching between Windows and Mac, and the shortcuts weren't the same between the two operating systems. And so I ended up just starting to learn the commands. And in my mind, I think move, copy, paste, add. So it's just easier for me to type the commands in. But that's just me. In fact, if I was to use this on my other computer, I have a 12-button gaming mouse that I use for macros. I would actually map the commands to the mouse so that I don't have to type anything in, which I guess is keyboard shortcuts. So you feel like an idiot for using Express PCB. Don't feel like an idiot for using any tool. In fact, one thing I would like to see change in the engineering community is shaming people for the types of tools that they're using. For example, some people believe you shouldn't use Eagle because it's not open source. Okay, that's perfectly fine, but I prefer the philosophy of use the tool that works best. So for example, one reason I switched to KiCad was that I needed to do a 4-layer board, and I didn't have the funds for a Eagle license. So after that, I just started using KiCad more and more. And so in that case, it was working best for me. Now, in your situation, if a different tool works best for you, then use it. You know, one thing I don't like is how people seem to think that, oh, you know, there's almost like an elitism around the types of tools you use. And I just think that's silly. I mean, use what works. If it gets your job done and you know how to use it, great. Now that said, I will say always have an allowance for learning new tools. So like in my videos, real quick. So most of my videos, the compositing tool I used to use when I first started was Motion. Really easy to get started with animating things. It's really, really powerful. At the time I was using it, the new version had just come out, so it was very buggy. And I kept telling myself I should try using Adobe's After Effects. And finally, one day I just said, okay, that's what I'm going to do. This episode, 100% After Effects. Took forever because I didn't know how to use it. However, what I learned along the way was it uses JavaScript in the back end. So I ended up writing a whole bunch of scripts to automate some of the things I do in the video animations I make. And so there I had an immediate benefit to learning a new tool because I learned more about how to use it. So I think what we're going to see in Eagle is, well, let's come back to that topic. Anyway, all right. I want to do, the next step I want to do is add values. And so if we look at the icon bar, this looks like name, this looks like value. So I'm going to hit value and say R1, and this is 6K, R2 is 68K. This capacitor is 10 microfarads. This one is 0.01. I think it's 0.01, yeah. Whoa. Microfarads, and then this resistor 1K. It's just to light it up. All right, so value, 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 value. Don't need one. I'm not going to name anything because I'm not going to do any silk screen. And so, okay, so let's just save this real quick as AddOhms Live Eagle 9. Okay, so that's looking pretty good. All right. Okay, so now I want to go over to, yay, new subscriber. Okay, so now we're ready to start the PCB design. By the way, real quick, I'll show you this because I did promise to say something. So this circuit we're designing is a 555 timer. It's to make a flashing circuit. And so if you're curious, oh, I thought I had the formula in here. Okay, never mind. I thought I had the formula for how that works out, but okay, let's move on to the PCB. And I need my design for that. Now, in this class I wrote, I actually talk about the DRC. I don't want to get into that. All right, this is what I want. Okay, so, oh, one thing I wanted to look at is info. So, info of R3 1K, so that must have been this one. It's just a resistor. So what I'm not seeing, like, I would have preferred a place where I could actually give this a part number. Having worked with in the component industry, that's one thing that I feel like is missing from Eagle right here. For active parts, you would put the part number as the value, but for passive components, I would rather put the passive value and then have like, so like if this was a chemic capacitor, I would have to do this, C0805C 107K 9 PAC, but I don't like that. Yeah, no. All right, so that's not how I'd like to see it, but that's okay. All right, let's save this and then click this button, and this will switch us to the PCB. Do we want to create it from schematic? We say yes. Okay, so what I thought was interesting, let me see. is I had this screenshot. Well, I won't get into it. So not only is this window very similar to previous versions, but even the way that the components get laid out down here ends up being the same, which I just thought was charming. Now, what is new is this thing over here called the Device Manager. And I peeked at that last night, but I'm going to come back to that later. So let's see if we can just shrink it down a little bit. Okay, so the first thing I'm going to do is we got to make our PCB. I went on and on and on about how consistent Eagle is, but right click. How do I move? Move, right click, group. Yeah, that's inconvenient. All right, view, zoom to fit. Nope. What I'm trying to get to is this corner. Just going to bring it down here. So when I first start out with the boards, I always left the grid really coarse so that I could get a nice squared off edge. All right. These are new. Manufacturing. Okay, that's cool. And I'll bet if I had 3D images for these parts, which I probably don't because back when I created my library, there weren't step files. But that, does this, no, okay. Actually, that's pretty cool just to have all that information in one place. And then Fusion Sync, I've actually tried to use this before, and I'm probably going to do a video or a stream on just that because that's kind of cool. Fusion Sync is where you can draw the board in Eagle and then import it or sync it up with Fusion 360. So you could draw, say, like your enclosure and have your circuit board. And then in the PCB, you could sort of move like a connector around. And then in Fusion 360, you could see where that would end up. And so that looks really powerful. I've seen some really cool demos on it, but I haven't had time to dig into how it works yet, so I can't show it. But that's one reason I'm giving thought to switching back to Eagle, is because I'm using 360 so much, it'd be really nice to just import my board designs directly in. That's not to say you can't do it with KiCad, because I do it today, but that's a different story. Okay, so right now all I'm going to do is kind of move these things around. And so let's move this over here. This is going to come down here. Its resistor is this one. This is going to end up around here. This is going to end up here. Well, now, like I said, when I drew the, I made a custom schematic symbol. And so I made the symbol so that, what do you call it? That the schematic would resemble the PCB. This was a training class after all. And so I do actually recommend, personally, I like drawing my schematic symbols based on how the parts will be laid out on the circuit board. I think it makes the schematic a little bit cleaner and makes it just easier to look at the schematic and then the PCB. Now on a super large pin count part, say like 144 pin or like a BGA or something, that's not really possible. And so maybe it doesn't work for larger parts, but for like a 555, why not? All right, we'll move this somewhere around here. Move this up here. So 1, 2, 3, got this one, this one, this one, this one, that part. All right, let's save that. See what you guys are up to. Yeah, Randolph, you're absolutely right. Yeah, I think you're actually pointing out probably my feelings for 360 integration is the promise is there, but it seems like there's still some hiccups. And so I'm interested to see if anything in 9 improved what I saw with 8. But yeah, I think it's getting there, and I would love to see something tighter. I mean, it seems like it would be a really big benefit, especially to smaller engineering teams. I guess bigger teams could benefit as well. To me, if it's me and maybe a mechanical engineer, or being able to better share our components would be, or assemblies, I'll say, would be really nice. Okay, so I need to rotate this one around Where's this guy? So that should go straight through there. Now, of course, I'm cheating a little bit because I've done this board a lot, so I already sort of know where some of these things should go. One thing, and I said this in my PCB video with the Pyramidino, when you design a PCB, do not hesitate to get about 25% of the way in and then just start over. Because to me, until you start laying some parts out and seeing where traces are going to go, it's really difficult to narrow in and hone in on what should the design actually look like. And I'm not going to do it on this one. I just realized there's no mounting holes on this board, so oops. Okay. Okay, so at this point, what I wanted to, the first thing they talk about is quick route. And so, as you can tell, I am not a fan of using auto routers. I don't trust them, literally, even though it's not my shirt, Chris Gamble, he made it. But I completely agree with it. I just have never successfully used an auto routing method. Now, I haven't used some of the more expensive PCB tools, so maybe when you get to more expensive PCB software, that maybe when you get to more expensive software, maybe it works better. But my experience has been auto routers cause more problems than solutions. But what I do like, and I remember Eagle had a little bit of route intelligence, which was you could get, as you were trying to place individual routes, there would be some intelligence behind what was actually happening. And so in this blog post where they're talking about what's new in 9, they talk about some of these new routing tools. So let's try them out. So the first one is Quick Route Airwire. Sorry, I just got distracted by Lumore. I remake it 20 times in different configurations. Yeah, that's exactly how I feel. Yeah. Randolph, you're actually talking about what I'm about to look at. Follow Me is actually the name of what it was. I just couldn't think of it. Okay, so what I'm going to do now is I'm going to select the route command, which if you're new to Eagle, a lot of people try to select the polygon line to draw traces. That doesn't work. You got to select the route command. And when you go to delete a route, you need to actually, you can't just say click on it. You can't just click on the route and hit delete. Oh, well, now you can. Okay, you used to have to use the rip up. Okay, anyway. Okay, so route, and then up here in the toolbar, these are the new things up here. And again, I don't know how new these are. The blog post says they're new in 9. I haven't used 8 very much other than to try out like the Fusion Sync. So I'm going to go by what Autodesk says and that these are new. So Quick Route Airwire. I think what this one does is if you click on an airwire or unconnected net, it will auto route that route. Okay. Actually, I do like that because I see like some value in that. Let me hit undo. So like, for example, this is totally a non-critical route. And so I really don't want to spend the extra few seconds to place it nicely. So, okay, so that's actually kind of nice. I need to move this around. All right, so let's go back to route and then route signal. Okay, so if this one is route airwire, then what's route signal? Oh, wait, signal. I'll bet, okay, let's try this. So I know this pad, and this pad are all ground. So if I say route signal, yeah, okay. So it goes and routes, does just that route. So I can actually see a really good use for that one. So like if we go back to the Pyramidino design that I was doing, if you remember that episode, I did VCC last. And to me, it was because that's the least critical route, since there's a ground plane for ground. All of the signal traces were done, and VCC pins have decoupling capacitors, so they can tolerate a few more twists and turns in the traces. Now, if there was a critical power route, then yeah, I'd do that one first. But I could see like doing like say like debug signals, or well, I guess those would be individual signals. But I see some value in, like, I just don't care about these, so just route them. So that's kind of cool. All right, now this one is route multiple air wires. I don't think this is going to be a good circuit for that. From what I saw in the blog post earlier, I think that's actually meant for like if you had, like, say, an address bus or a bunch of data lines. So that could be a huge time saver. And then this one is, I think this one says smooth, which I didn't understand what this does. Yeah, I don't know what that does. So not really interested in that one. Okay, so that's actually pretty cool. Let me go ahead and okay, let me think. I don't actually want some of these. Okay, so let's do this. Do that. Okay, so let me come back to my preview. All right, so what happens if I just say I'm a stubborn engineer and I want to do it myself anyway? So let's see, we got push obstacles, walk around, and ignore. So ignore, I bet, will let me just do whatever I want. Okay. And then let's try, what's this one? Walk around. Let's see what that does. Okay. So that actually, and I think that might have been, Randolph, maybe you can remember, that might have been closer to the follow me that Eagle used to have, which I actually like that one, because on a simple circuit like this, it's not a big deal. But like when you start getting to, say, like if you had 6 IO pins and you're trying to get around vias or something, this is just nice because it keeps you from having to click a bunch of things. In fact, I'm going to leave it on that and just see if it ever irritates me. Okay, so that doesn't look right. I think I have this backwards. Is there a rotate on here? No. Something's wrong. Hold on. Because this should be going to VCC. Let's come back to the schematic real quick. VCC threshold to ground. Did I put a capacitor here by mistake? No, that's R3. R3 LED. Pin 4. Oh. Okay. I don't understand why this old schematic doesn't line up. I think I did the schematic wrong. Yep. Okay. That's what's going on. I had R connected to, I had reset connected to the out, where what should have been output. This actually connects up to here. Let's add a junction. And then the output Q goes to here. Okay. All right, that's a lot better. Okay. I knowed it was wrong. I just couldn't tell what was wrong. All right, let's go to grid. So I still have to, is there another place I can change the grid? I guess here. So 25, and so 25 is the natural movement, and then if I hold down the Alt key, it'll go by 5 mils. So I always like to do that. And then once I get to silk screens, if I use them, then I change this to 1, so I get really fine pitch. All right, so let's go ahead and just get this thing, route it to here. I don't know why that's lit up. This LED is backwards. All right. You know what? I don't feel like doing this right now. Oh, but I need to. Okay. Okay. I'm already bored with this. Not Eagle with the circuit that I have. So I'm going to go back on what I originally said. I'm going to go ahead and just use this route thing. All right. I don't understand why that's complaining, but that's okay. We'll just kill that. Let's route this one. That one's an easy one. That's an easy one. VCC and the signal. This needs to, can I just do rotate? Nope. Move. I keep doing the move command instead of right click rotate because I want to be able to right click twice to rotate it. So let's get this one routed. This one goes through there. This one comes down here. Okay, there we go. So this isn't exactly how I did it in my previous design. Okay, I don't like doing vias underneath chips if you can avoid it. How did I do this before? 1, 2, 3. This one. Connect it to, yeah, okay. All right, so its little tool did not work out. I'm not sure if it's trying to stick to one side of the board or what, but I need this. Oh, so that time it worked. What did I choose different? Huh. All right. Okay, nothing left to do. Okay, not the most elegant route, but hey, that'll work. I want to move on and see some of the other stuff. Follow me, it'll post super videos. I'm not sure if walk around does that. Yeah. I'm really not liking that it put vias under a chip. I feel like there should have been a way for it to know. I just, in general, especially for lower cost PCB operations, putting vias underneath components can be dangerous because now, well, let me back up. If you're going to hand solder, it's probably not a big deal. But if you're going to do any kind of reflow soldering, even with a toaster oven, what you want to be careful of is a via underneath a component, whether it's a chip or a resistor or capacitor. That via, if it gets any solder mask inside of it, or when it gets electroplated and tinned, that solder that's in the via can actually bubble up a little bit and create a bump. And so whatever the component's on will put some pressure on the underside of it. And so in general, I try to avoid vias directly underneath a component just so that there's no issues when it gets soldered. Again, if it's a high quality PCB process or you're hand soldering, it's not as big of a deal, but it's just something to try to avoid. Also from a debug perspective, vias are really nice because you can actually scrape away the solder mask and use them as test points. Okay, so that's kind of the routing thing. Again, I'm not going to look at the auto router. I don't care. I will probably never use it, but I am thinking with some practice, these automatic routing tools, the follow me kind of thing, or the auto air route, I can see a lot of time saving happening. In fact, remember I was just saying do your board multiple times. I could actually see a value of, okay, let me just click a bunch of these routes and see what Eagle suggests, and then roll back and say, okay, let me move some things around and try something out. So I can see it as a time-saving tool, especially if you're trying to figure out where to put things, because if you're just placing components around, why waste all your time carefully routing something? So that's pretty cool. Okay, I want to move on and just double check chat one more time. Okay. All right, let's go to the blog. How's this thing looking over here? Okay, let's go back to their blog post and see what else they had as new features to check out. It's wrong browser. Okay, so quick route signal, multiple signals. Yeah, this is what I was talking about. The example I'm using isn't really good for showing the multiple signals. Quick connect. I'm going to come back to that. Spoiler alert. I saw a demo of this, and so I think I know what this does, but I want to come back to it. The next thing I wanted to look at was this design manager. And honestly, when I first looked at this last night, I was going to completely skip over it because I was like, okay, what does this board have to do with PCBs? And then I didn't quite follow what the description was. And then I realized that this is the design manager. I mean, it says design manager, but I didn't recognize it. And so what's kind of cool about this is between this and the manufacturing tab, one of the things that I'm really liking in the direction that Eagle's headed here is bringing more information to the surface. And so if all you want to do is draw a board and get it manufactured, these panels probably don't really do anything for you. But if you need to do any kind of analysis or evaluation of the board design, these I can see being very, very powerful. Okay, so manufacturing tab, I don't want to look at. So devices, first off, there's a couple of device sets. And so there's all the devices listed. And so this is all the components in our design. And then you can narrow it down by what's on the top or bottom of the board. Okay, now what I didn't find is I didn't see any way to create your own device set. I don't know if I missed it or if you're stuck with whatever's already predefined, but not a big deal, or at least not a big deal yet because not really paying attention to it. So even here, I already see something that I really, really appreciate out of the tool is, okay, I have my parts on the top side and I can see the column for package and I can immediately at a glance see I use 1206 for all of my parts. With my current design process, because what I normally do is I export the components from my tool and then upload it directly to DigiKey, which already has all my passive part numbers. I sometimes miss that I selected an 805 package instead of a 1206 or a 603 instead of an 805. And so I just end up with a couple of extra parts that I don't really tend to use. So I just like being able to look at this and say, okay, here's all the footprints. That looks really good. This other information, not sure how useful it is yet, but it's there. I also like that you can go through and then identify each of these. And I really am liking the idea that once you click on one, so let me do a capacitor because it's simpler. So we're looking at this one, C2. This items breakdown lets you see what all of the pieces of the footprint are. Again, from maybe if I just want to create a board and get moving, it's kind of a don't care. If I was looking at KiCad, you can get all this information, but you sort of have to go into the text file and see it. But I just like that I can see, okay, this symbol has this information on these layers. That's really helpful to me because if I wanted to make sure that everything was where I expected it, I could easily see it. And so I'm liking that. So that aspect of what the devices are, I like to see all that information in one place without having to leave Eagle. On the signal side, we have something that I should have paid more attention to when I first started, because one of the first things you'll notice up here is the ability to create net classes. And so I don't remember being able to do this in previous versions of Eagle. And so if it's there, I just missed it. I do know you could predefine the sizes of different routes, or there was a drop down that you could modify what the routes were, but you couldn't really do a class. So for example, let's say we were using OSHPART to make these boards. We could say, okay, by default, how do I edit this? Edit net classes. So I want the default to be 6 mil, the drills to be, I forgot what the minimum drills for OSHPART are, so don't use these. Go look at their site, make sure they're right. And then a clearance of 6. And actually, I even like to do a clearance of 8, even though they allow for tighter. Just if I can make the clearance wider, I like to do that. And then I usually create something like a power net where I make everything a little bit bigger. The drill is going to be the same, and then clearance will do the same as the width. Now, at this point, all of my signals are in the default group. And so if I take, say, for example, ground, how do you then put this into power? And VCC should go into power. All right, so now I'm looking at, here are my individual traces, and then here are my power traces. Now, I haven't verified this, and if this is how this works. This is really cool. Is this, so this says trace mils 1,936 mils. So is this telling me that this is almost that the sum total of the trace is 2,000 mils? If that's the case, that's really cool. Not because of something like a ground signal, which should have been a ground plane anyway, but if you're doing like a power distribution network or a differential signal line, this can be helpful to make sure that certain signal traces are a known or specific length. So that's kind of a cool thing if that's the case. All right, and then down here are, I think this is telling me what items are connected to these nets, which is again useful. You know, I mean, is there anything groundbreaking in being able to see this information? I mean, not really, not the information itself, but being able to see it in a nice, consistent, single place. I'm really liking that. And so this is something, if I switch back to Eagle, I want to explore a little bit more, understand how that works a little bit better. Okay, I'm new to Eagle, but what happens if you don't ground your PCB? I believe it's the polygon option. Yeah, okay, I want to try that, because that was actually one of the original tutorials I did. Was let's see. So how do you do a ground plane? Polygon. I'm just going to select this. Is it? Okay, let's try this. Okay, and I want it on the top side. I'm going to do that. And then go info, and this does not let me do a net. Okay, so let's undo that. So do we have to do a polygon? And I'm going to do orthogonal and just do this. Go here. All right, go info. All right, and yep, now I can add it to ground. Solid, isolate 6, width 6, net class, power. Okay, ground already exists, use name. Okay. 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 Okay, now it's ground, isolate still 6, and man, I was really hoping that this wasn't necessary still, but you still have to hit the rat nest button to get the polygon to fill. I would love for somebody from Eagle to explain to me why that's still the case. 10 years ago, I would argue that computers were powerful enough. 20 years ago, maybe I could have understood why you wouldn't want to do that kind of complex fill, but come on. I wonder, is there an option somewhere that you can actually tell it to stop doing that? Because that would be great. But anyway, all right, Luis, that's looks like you still have to use polygon to make the, or do you? If we did a rectangle, can I name that? No. Yeah, okay. So you still have to do a polygon. Not the end of the world, just I feel like that could have, like, rectangle should work, and I feel like you shouldn't have to hit rat's nest. Okay. All right. All right, new subscriber. Okay, now I want to get to the thing that I've seen a demo of, and so I really want to see how well this works. So I'm going to save this in case we want to come back to it. And then we're going to do new. Okay, so in the DIY Arduino schematic episode I did, I broke out all of the I/O pins on a 32U4, which, it was only like maybe 10 signals or so, but I got really tiring of drawing the line, labeling it, drawing the line, labeling it, drawing the line, labeling it. So check this out. I'm going to go to add, and I want a component like a chip that has a bunch of lines, a bunch of pins on it. So let's go look for an MSP. The MSP 430 is what is featured in the launch pads, which there is a software project called Energia. You go to energia.ru, and if you know the connection to the name, as well as if you know why it's called Energia, a little bit of trivia. So if you know why, say so in the chat. But Energia is basically an Arduino implementation for the MSP 430 / Launchpad, which is really cool. It makes it really easy to use launch pads. In fact, in the pull-up resistors video, I used my Launchpad in the Arduino IDE, which made programming the 430 super easy. So anyway, really cool chips. I don't know them as well as, say, like AVR, so I don't know what I'm actually picking right now. I just want something that has a boatload of pins, and this package style looks like something I would actually design with, so I'm going to select this one. So, okay, get out of there. All right, so we see we've got a bunch of pins. What is it? Probably like 64, right? All right, so all the pins are there. Now, let's say I wanted to break out all of these lines. Well, I could do this, and I could go, okay, name, derp. And it just takes forever. So check this out. I'm going to right click and say breakout pins. In this case, I'm just going to do all pins. Unique. Done. I absolutely love that. Being able to get all of my IC pins broken out, they're named. Maybe the names aren't what you're used to using, so okay, you got a little bit of a hiccup there, but I really enjoy the idea that I could go create my own symbol, name the pins the way I want. That would create my my nodes around the schematic the way I want. Basically, if I wanted to go and then add these to an I/O header, you create a bus, drop the bus down, expand it. This, I think, to me, I don't know. This is listed in the blog post as new in 9. If it's not new in 9, I apologize, but I saw this and was like, okay, you got my attention. This is going to be something that I really want to come back and take a look at. So, okay, so those were the major things. So let's kind of back up. What do we do here? So I went through an old design I had of a 555 circuit just to see from a usability perspective. There have been some minor improvements. I don't know that they were necessarily Eagle 9, but Eagle has continued to improve over the last couple of years, so I'm happy to see that. And so just if I wanted to sit down, draw a schematic real quick, or draw a schematic, draw a PCB real quick, it's possible. Now, the trade-off is you still have a little bit of a learning curve with Eagle, but as I said very early in the episode, once you understand how Eagle operates, it's a very consistent user experience. And so if you can put the effort up front to understand how it's operating, it's not like you're constantly learning how do you copy something. But even there's been a lot of improvements. Then the next thing we did was we looked at a lot of the, or not a lot of, but create from schematic, yeah. So then we looked at what changed in the PCB editor, liking the new design manager. I think that's going to be a helpful thing. The way that the auto routes work, not the auto router, but the auto routes work. I can see that being a time saver. And then again, I just think this breakout feature, I have to think from a programming perspective, this couldn't have been a terribly complicated thing to come up with. But the insight of, hey, a lot of people keep doing this same thing over and over. Let's just add that as a feature. That I'm really happy to see that. And I'm probably sensitive to it because I feel like this is what I waste most of my time doing. I haven't looked at it in detail. Okay, so those are the things we looked at. Let me know if you have any other questions about Eagle in the chat. I'm going to go check some of the other chat channels to see if anything's there. I just remembered a friend of mine showed me something, add design block. Yeah, so I don't know when this got added. I think this was with version 8 because I remember seeing this like weeks ago. But I don't know if it was a public version that I looked at. So this says 3.3 volt regulator based on an LM317. Click OK. And so I don't know what this is. Paste from file. Is that all this is? Is just the old paste from file? Okay. So, okay. One thing that's always bothered me is I reuse a lot of my design blocks, and I always feel like I end up redrawing things over and over. So I see this as an opportunity where I could have the design block already done. Here's what I want to know though. Let's save this. We'll just go desktop. Untitled's fine. Come to the, okay. So what would have been really cool is if the PCB layout actually followed with it, but even this will save some time. And actually, now that I think about it, the PCB layout might be useful for certain things like a switching regulator where you've already figured out the optimal layout, or maybe like the oscillator for a microprocessor. But outside of that, you probably end up moving things around. I still would have been nice if you could have like a basic block you just drop into both the PCB and the schematic. So that's kind of cool. What else is in here? Oh, wow. Okay. Oh, wow. Hey, that can be useful. Okay, I see what they did. Okay, that's actually okay. I see some value in that. Wow. Okay. So if you wanted to incorporate, say, like an Adafruit module, I guess, yeah, I guess what this is this. I think this is just a list of existing schematic and board files. Um, that's that's still useful. It's still cool. I just I do like this. Yeah, look. So Randolph is saying I thought the boards were in there. I think what's happening is maybe like on this Adafruit example, because there's a schematic and PCB or schematic and board file that exists, they must be shared. So that's actually pretty cool. Um, wow. Okay, this feature by itself, which I'm not sure if it's new to 9 or not, but this is something I can see use in because especially for the first cut of a circuit board, I'm usually going from breadboard where I have things like Adafruit modules to a circuit board which starts to incorporate the Adafruit design into my design. And so a first step might actually be, let me just copy their exact circuit and then validate that I've got all the connections on the PCB right, and then optimize after that. So I really like that. That's pretty cool. Okay. All right. Anyone else in the chat know something I should go look at or questions? Dip trace rules. Well, sorry, man. Got to ban you for that. Just kidding. Okay. All right. I'm going to hide my screen for just a second. My secrets are all to belong to me. All right. That's going, that's going, that's going. Okay. All right. Let's come back to this guy. Okay. All right. Well, so as I sort of set out for, this was just I wanted to check out Eagle 9, and I figured I'd do it while I was on camera. I know I've probably missed a bunch of cool things, especially because I haven't been using every version. But I think from okay, where's my mind at with Eagle right now? So from what I can see, there's still the free light version, which looks like it has similar restrictions that they've had for years. Looks like 2-layer board, certain size, does enable the auto router, which So that's good. And then there's looks like a standard and premium version. And when I looked last night, I didn't look at the premium price, but the standard version was like $100 a year. And I know subscription pricing is a sensitive topic, so I don't necessarily want to get into a discussion about the idea behind subscription modeling. But what I will say is uh, for other products that I have, other software products I have, I'm finding the subscription model to be actually be a benefit. Now, I know a lot of people are going to say, oh, no, it's not because it ends up costing more, blah, blah, blah. Okay, fine. One thing to think about with a CAD tool or a tool you don't use often, it is nice to be able to subscribe when you need it. So like if I only need Eagle for one project, or maybe like 3 months out of the year I do Eagle designs, I like the idea I could save some money and only subscribe when I need it. The downside to it is, okay, if you're a little bit like me and say, okay, well, what about 2 or 3 years from now? I remember how to use Eagle 6. I don't necessarily want to put the time up front to learn how to use the new version, if whatever that is. So there's a downside to that. So I'm not, again, that's all I'm going to say on subscription pricing. It looks like it's there. I don't think $100 a year for Eagle, if you need the capabilities that are different between standard and light, is an outrageous price. Outrageous price. I think it's reasonable. You know, just when I look at some of the softwares out there, they're quite a bit more than that, and so I think it's an interesting price point. So it'll be interesting to see. I am happy to see for now, at least as of now, not for now, as of now, there's still a free version, so that's good. And I think from what I looked at here, I think the free version is going to do a lot of good for a lot of people. Okay, all right. I'm going to end the stream at this point. A couple of things that are coming up. I'm actually working on a portable Pi build, which I hope to have finished this week. And then after that, I'll be doing the assembly of the Pyramidduino. And I'm thinking I might actually live stream the assembly process of that because I get really bored and it'd be nice to talk to somebody while I'm doing it. And then after that, I've got some stuff related to oscilloscopes coming, which I'm really excited about. If you'll notice in the back, my friends at Rohde & Schwarz were nice enough to send me an RTM 3000. And I want to talk about scopes. I want to talk about scope probes. And then I think if I can come up with a circuit that does a good job, I'm going to compare a Scopes FFT to an actual spectrum analyzer. And so those are some of the things I'm working on. And stay subscribed, all that jazz. Follow me, AddOhms, Bald Engineer. And so you can see when all that stuff is available. Thank you for coming by the stream. Thanks for everybody in the chat. Thank you for the people that stayed civil. And if you have any questions, I'm going to stick around for just a few more minutes in the chat room. You can also find me on Discord. I've added a link to the description on the description for this video. My name is James. I'm the Bald Engineer. Thanks for stopping by.